Hey guys, so the first video I basically just talked about some vocabulary, your perfect squares, your perfect cubes, and now I really want to focus on simplifying non-perfect square roots. You can all tell me that the square root of 121 is 11, that the square root of 25 is 5. But I really need us to focus on this when we do not have perfect squares, okay? So if you're going through our notes, which you should be, it kind of breaks it down for you and says that the first thing you should do is find the largest perfect square that the radicand, it's a number in the house, is divisible by, and then break down the radical using that number. So if I'm looking at 32, all right, the number, the perfect square that's closest to it is 25. Well, obviously 25 does not go into 32. All right, then I keep going down my list, and this is where it comes in handy if you've memorized them and you know them. The next highest perfect square is 16. 16 does go into 32. So I can say that the square root of 32 is actually the square root of 16 times the square root of 2. Now, the square root of 16 is something you all know. So square root of 16 is 4 times radical 2. Now, you're not going to see it written this way. You're going to see it written as what I call a squish. All right. So 4 radical 2 is radical 32 simplified. All right, so let's look at the square root of 180. This one might be a little bit harder because it's a little bit higher, but I need to start thinking of square roots that are around it. And if I start to go through my list, all right, I know 25, no, I'm trying to think of all these things that might go into it. You might say 4, all right? 180 divided by 4, does that work? But the question is whatever you're finding the largest square root? And the largest square root that goes into 180 is square root of 36, and it would be times the square root of 5. All right, square root of 36 is 6 radical 5. Now, I'll admit, the second one's a little bit harder, so I'm going to show you a different way to do it. Sorry, my camera's a little wobbly. I'm trying to record this and write, and it's just not working beautifully. So one of the things I want to talk to you about is that next year, you're going to be expected to be able to do this, okay? Ms. Fry and Mr. Manise are really going to expect you to be able to find that largest square root. However, if you absolutely stink at that and you can't do it, you just can't. There is a way that you can do this using prime factorization. So I'm going to show you that for the square root of 180, okay? So if I don't know how to do this, all right, I'm going to come over here and I'm going to start breaking down 180. All right, so 180, I know to multiply or to get 180, I could do 18 times 10. That one's pretty obvious. All right, now I've got to break these down to prime numbers. All right, so 18 could break down into 2 and 9. All right, 2 is prime. 9 is not prime because what can we multiply to get 9? 3 and 3. Okay, now I circle my prime numbers once I get down to that point so that I don't lose them. All right, 10 can break down into 2 times 5. Both of those are prime. There's nothing else that goes into them. So then I would rewrite that over here as the square root of, I write the numbers that are alike beside each other. 2 times 2 times 3 times 3 times 5. So then I have this. All right, and this is my prime factorization. You did this 5th grade, 6th grade, not really sure. Now what I'm looking for, because I'm looking for a square root, because there's an understood 2 right there is my index, I'm looking for groups of 2. So here's a group of 2, and here's a group of 2. You're looking for a party. All right, they got to have a date to go outside the house. That's the way one of my teachers used to teach it. So this set of 2s would come out as a 2. This set of 3s comes out as a 3, and the 5 is left inside. Now, isn't your final answer the same thing as you got above? It is. All right, so it kind of depends on you and what you're best at. On how you're going to solve it. Again, your teachers next year are really going to want you to be able to use this right here, but if you're really struggling, you can always do the prime factorization.